Hey guys, in this video we're going to go over page 4 of the Math ACT. This is questions 24 through 31. So being that this is 8 questions, just like in the last videos, our target would be for this to take us about 8 minutes. I recommend you pause the video and try these 8 problems, aiming for about 1 minute per problem, so about 8 minutes total, or just time yourself and see how long it takes. Or I'll also give you time throughout the video to pause before each question and try it on your own before you see the solution. I do also have timestamps in the description, so feel free to skip around in this video if there's a specific problem you're looking for. With all that said, let's get started. Number 24 says the set of all positive integers that are divisible by both 15 and 35 is infinite. What is the least positive integer in this set? So first let's unpack some math vocab here. An integer is just basically a whole number. It can be positive or negative or 0, but no decimals or fractions. So if an integer is divisible by both 15 and 35, it just means that 15 and 35 both go into that number. Obviously, there's lots of numbers that 15 and 35 could both go into, so that's why they say it's infinite. So least positive integer just means the smallest number that you can come up with that's positive, not negative, that 15 and 35 both go into. Well, I can rule out 5 and 50 right away. 5 is way too small, and 15 and 35 both don't go into 50. I'm not sure about the other ones, though this is getting a little bit bigger. So let's look at multiples of 15. So we have 15, 30, 45, 60, 75, 90, 105, and 120. I noticed 105 is in there, so let's stop with the 15s and see if 35 goes into 105, just by counting by 35. So 35, 70, and then 105. So 105 is the smallest number that 15 and 35 both go into. And I don't need to check the other ones because 105 is the smallest number we have available to us now. So the answer is H. Number 25 says, in triangle ABC shown below, the measure of angle A is 58 degrees, and segment AB is congruent to segment AC. What is the measure of angle C? So going back to geometry, there's a couple things we have to remember about triangles. First is that all 3 angles should add up to 180 degrees total. The other thing is that if 2 segments are congruent, that means they're the same length. So AB is the same length as AC. And we can use this little notch mark here to demonstrate that. And that actually brings me to the next thing we need to remember about triangles, and that's if these 2 sides are the same, the angles opposite them are also the same as each other. So whatever the measure of angle B is, it's the same as the measure of angle C. So if I add up 58 plus angle B plus angle C, that should add up to 180. Except B and C are the same thing. So if we keep B and C together and subtract 58 from both sides, we get 122. And then if we divide 122 by 2, we'll get 61. And the reason I'm dividing it by 2 is because both of these angles are the same. So angles B and C are both 61 degrees. So the answer is D. Number 27 says, on the first 7 statistics test of the semester, Jamal scored 61, 76, 79, 80, 80, 84, and 91. The mean, median, and mode of his scores were 79, 80, and 80 respectively. On the 8th statistics test, Jamal scored 90. How do the mean, median, and mode of all 8 of his scores compare to the mean, median, and mode of his first 7 scores? So let's take a look at the mean first, since that's the first column. If we look at the original set of test scores, it said the mean was 79. But then we're going to add in another score, and it was 90. And that would go here. Like if you look at this list, it's actually in order from least to greatest. So the 90 would go towards the end. So since we're adding in a score that's much higher than the mean, which is at 79 right now, it's actually going to drag the mean up a little bit. So we can rule out answer A. Next, let's take a look at the median. The median is just the middle of a list of numbers, if they're in order from least to greatest. And this one is in that order. It said originally the median was 80. Let's look at the middle of this list of numbers. I'm going to cross them out from the left and the right. So cross those 2 out, cross these 2, cross out these 2. And so we're left with 80 and 80. Now, this is kind of a silly example, but just in case you have a different type of question on the test, let's talk about how you find the median here. Obviously, the median is 80 because that's the only thing we have to choose from. But if these were 2 different numbers, and there's 2 numbers here, right? So there's no actual middle number. What we'd want to do is just add these 2 together and then divide by 2. So you take the average of these 2 numbers, basically finding exactly the middle of them, that would be the actual median. But in this case, it's 80. So again, we can rule out, obviously it wasn't A, it can't be B or C because we know the median is still the same, it's still 80. So last, let's take a look at the mode. And it said the mode was 80, and remember the mode is the most commonly occurring number. So we have the two 80s in the original list of numbers. And if we add that 90 back in, that doesn't change the mode. There's still these two 80s, and there aren't any other numbers that repeat more than that. So the mode is equal. So the answer must be E. Number 28 says, the solid rectangular prism shown below was built by alternating congruent black cubes and white cubes, such that two cubes of the same color have at most one edge touching. What is the total number of white cubes that were used to build the prism? I just want to point out quickly that this is an example of a problem where you don't really have to read it. It explains how this cube was built, but they also give you a diagram. So there's really no information written in the problem that you need to know, that you can't figure out just from looking at the picture. Obviously, the tricky thing about this is we can't see inside the cube, so we can't count every white cube that we're looking for. But if we just take a look at one of these slices, like the first slice, the first face that we can see, let's count how many white cubes there are there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Now, if you notice, there's the same number of black cubes as there are white cubes on every one of these slices. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. There's 21 of each. So what that means is as you look at every slice from the front to the back, it doesn't matter that it's alternating with a white or a black cube or what it's starting with. There's the same number of white on each slice. There's 21 white cubes on every slice. And there's 1, 2, 3, 4, 5 slices total. So if you do 5 times 21, you get 105. So the answer is H. Number 29 says one side of square ABCD has a length of 12 meters. A certain rectangle whose area is equal to the area of ABCD has a width of 8 meters. What is the length in meters of the rectangle? So let's draw out square ABCD, roughly a square anyways, ABCD. And it says one side is 12, but it's a square, so obviously both sides are 12. And then we know we have some other rectangle. We don't know much about the rectangle, but it has a width of 8 meters, and it has the same area. So the area over here is 144. Must mean the area over here is 144. But if we do 144 divided by 8, that'll get us the length. And the reason we're doing that is because area equals width times length. So if you're trying to solve for the length, you just need to divide both sides by the width. So if you take the area, which was the 144, and you divide that by the width, which was 8, you'll get the length. And you get 18 from that, so the answer is C. Number 30 says the average of a list of 4 numbers is 92.0. A new list of 4 numbers has the same first 3 numbers as the original list, but the 4th number in the original list is 40, and the 4th number in the new list is 48. What is the average of this new list of numbers? So let's first visualize our first list of numbers. We had 1, 2, 3, 4, and it told us that the 4th number in that is 40. We also know that the average of those 4 numbers is 92. So if we take and add these 4 numbers up and then divide by 4, that should give us 92. Our next list has the same first 3 numbers, but the 4th number is 48 instead of 40. And we want to know what we get for that average after we add all 4 numbers up and divide by 4. And in algebra, you learn to use things like x, like a variable, to represent some amount that you don't know. Right? So we could look at these 3 numbers, and I know they are 3 separate numbers, but it doesn't really matter what each one of them is. We're just looking at them as that chunk of 3 numbers, which is the same as this chunk of 3 numbers. So let's just call that whole thing x. And we could actually solve for x if we get rid of this 4, so we'll have to multiply both sides by 4. I know this is getting pretty messy. But we'll multiply both sides by 4, and then we'll just subtract this 40. So 92 times 4 is 368. And then if we subtract the 40, so we just get those 3 remaining numbers, we get 328. And that's what we're calling x in this problem. So all of this stuff here is 328, and that means that it's also 328 down here. And that's all we need to know, because now we can do 328 plus 48 and then divide by 4. And you should get 94. So the answer is H.